So we want to find closed formulas given recursively defined sequences. We have a problem here where our first three terms are given. The first three terms, these are called the initial terms. F of 0 is 1, f of 1 is 0, f of 2 is 2. And the nth term is defined to be 2 times the n minus 3 term. So let's write out some of the terms of this sequence. So we're going to start with, let's say, f of 0. That one's 1. F of 1 is 0. F of 2 is 2. Okay, so we actually have those first three given. Let's scroll a little. So to find the remaining terms, I can't find, well, I don't have f of 3 off the top of the given here. So we have to find that, right? F of 3. So to find f of 3, we're going to take, what, 2 times f of 0. In other words, 2 times 1, which is 2. And f of 4, let's think about that. That's going to be, what, 2 times f of 1. In other words, 2 times 0, which is 0. And f of 5, that's a dude. 2 times f of 2. 2 times, well, f of 2 was 2, so 2 times 2 is 4. Right, f of 6, it's going to be 2 times f of 3. In other words, 2 times, what was f of 3? It was 2. That's going to be 4. How far do we want to go? Let's go a few more terms. Let's go 2 more terms. F of 7, that's 2 times f of what? 4, which is 2 times 0, which is 0. And then f of 8, we'll stop here. I think that'll be enough. 2 times f of 5, right, which is 2 times 4, which is 8. Let me go back and look at my terms. So we get kind of a pattern, right? We get 1, 0, 2, 2, 0, 4, 4, 0, 8. It looks like things are broken into kind of clusters of 3, a pattern of clusters of 3 here. 1, 0, 2. 2, 0, 4. And 4, 0, 8. Dude, get back in there. Yeah. So I'm going to call these first ones the single stars. So we have 1. F of 0 is 1. F of 3 is 2. And f of 6 is 4. There's kind of a pattern, right? The 0 here, it's the input, is a multiple of 3, right? It's 3 times 0. Okay, now let's go back. F of 3. Notice that 3 is a multiple of 3 as well, right? It's 3 times 1. And let's go to f of 6. Right, f of 6 is, well, the 6 here is a multiple of 3. 6 is the same thing as 3 times 2. Okay, so you notice that your inputs for each of those first types are all multiples of 3. Let's pay attention to our outputs, right? Our outputs are powers of 2. So the output here is 1, that's what? 2 to the 0th power. And then going on to f of 3, the output there is 2. That's going to be what? 2 to the first power. And then when I go to f of 6, the output is 4. That's going to be what? 2 to the second power. So they're all powers of 2. So I think I'm developing a game plan. It looks like all the multiples of 3 there have an output of 2 to the k, right? I have 3 times 0 goes to 2 to the 0, right? 3 times 1 goes to 2 to the 1. 3 times 2 gets sent to 2 to the 2. So let's see if we can come up with a function for those multiples of 3. What color here? Red. I'm going to put my closed form down here at the bottom. Closed form. Say f of n. So if n is a multiple of 3, so we write that as 3k, then the output is 2 to the k power. Right? So if you have a multiple of 3 as your input, if your n is a multiple of 3, the output is 2 to that power, that k power. So now we want to look at the second type of terms. I'm going to call these the double stars. The double stars upon the r's. That'd be f of 1, f of 4, and f of 7. So think about f of 1. So 1 as a number, you can write that as 3 times 0 plus 1. Right? 3 times 0 plus 1. That's what 1 is, right? It's 3 times 0 plus 1. Let's go to 4, f of 4. F of 4. So the number 4, that's going to be what? 3 times blank plus 1. 3 times 1 plus 1. And let's go to f of 7. Seven is going to be 3 times blank plus 1. 3 times 2 plus 1. So it looks like for these second types, right, we have 3 times 0 plus 1, 3 times 1 plus 1, 3 times 2 plus 1. Those are all of the form. The inputs are 3 times k plus 1, and the output is 0. Right? The output for each of these is 0. It's always, wait a second, what was that? What was that? Get back. The output was 0. The output was 0. So yeah, when you have 3 times k plus 1, when that's the form of n, you're going to have an output of 0. So let's go down and put that in. So we said the output is 0 if n takes on the form 3 times a k plus 1. Okay, so we got the second type figured out. Now we want to do the third type here. That's going to be f of 2. We're going to put triple stars upon the r's. This is not good. There we go. The pen's working. So f of 2, we're going to write this as f of 3 times blank plus 2 equals f of 2. Alright, I lost my f there. This thing is not working. So 3 times blank plus 2, 3 times 0 plus 2 gives you 2. That's a 0 right there. All right, let's do this triple star here. Triple stars. So we're f of 5, that's f of 3 times blank plus 2. So it's going to be, what, 3 times 1 plus 2. That's what 5 is, right? 3 times 1 plus 2. Scroll a little bit down. Let's go to the f of 8 situation. Another triple star. We're going to have f of 3 times blank plus 2. All right, so 3 times what plus 2? 3 times 2 plus 2. And then let's observe what the output is. It looks like the output here is 8. 8, right? And that's a power of 2, right? That's going to be 2 to the third power. So 2 to the 2 plus 1. All right? That's what 8 is. 2 to the 2 plus 1. 2 to the third. And when we go to the triple star above that, f of 5, well, this is what? 4. The output is 4. F of 5 is 4. That's 2 to the 2, or 2 to the 1 plus 1. And let's scroll up. Let's go to the third type on that first group of 3. So when we have f of 2, you get 2, right? That's 2 to the 0 plus 1. Oh, come on. Come on. You can do this. Right? 2 to the 0 plus 1 is 2. So notice that when we have 3 times 0 plus 2 for an input, we have 2 to the 0 plus 1 for an output. When we have 3 times 1 plus 2 for an input, we have 2 to the 1 plus 1 for an output. And finally, when we have 3 times 2 plus 2 for an input, we have 2 to the 2 plus 1 for an output. So for this third type, the triple star type, we can summarize that as follows. The output here is going to be 2 to the k plus 1 if the input n is equal to 3 times k plus 2. So that's one way to actually write the closed form of your equation. It's actually piecewise. Now, if you want to, you can rewrite this. There's another way to rewrite this. There's an alternate way. So basically, you can solve for the purple k that's above the green 2. So if I were to do that, let's see, I got f of n equals 2 to the blank if n equals 3 times k. So let's say I got n equals 3 times k there. I divide both sides by 3, right? I get n over 3 is equal to k. So rather than putting that purple k, I can put an n over 3. Okay? The second one is just going to be 0. There's nothing special about that. If n equals 3k plus 1. And then the third one, we can do a similar thing. We can do 2 to the, and replace that k there with something in terms of n. So we're going to take n equals 3k plus 2 and solve that for k. So let's say I take n equals 3k plus 2, subtract 2, and then divide both sides by 3. I get n minus 2 over 3 equals k. Let me scroll that a little bit. It didn't come out too well. Come on. 3. Right, so k here is going to be n minus 2 over 3. So instead of writing that purple k and then plus 1, we can put that, come on dude, freaking work, n minus 2 over 3 in place of the k, and then a plus 1 as an exponent. Yeah, so here's another way to do it. Here's an alternate way to do it. I don't care how you do it. Either one is good to me.